Hey guys, so today I'll be showing you how to code a genetic algorithm in Python. But first I want to explain it so you get a thorough idea about its use case and everything. So let's get started. Explaining genetic algorithm. Okay, first what is a genetic algorithm? What is it? What is its use? Why do you need it? A genetic algorithm is used for nonlinear and non-differentiable optimization problems. They use concepts from evolutionary biology to search for the global minimum to an optimization problem. Here's a little example there. Why is genetic algorithm called genetic algorithm? Why isn't it called something else? It's called genetic algorithm because it does mimic evolutionary techniques. Here's another one. Here's a little example here. How does it work? Genetic algorithms, well, first it starts by creating an initial amount of candidate solutions, like answers, and then are tested against the objective function. What's the objective of the function? It then generates later generations from the first generation, from things like selection, crossover, and mutation. Now, what is selection, crossover, and mutation? Well, selection first. It's to retain the best performing bits from one generation to another. An example is this. So, like, it would be parent with this. Let's say this is the best. Then crossover would go selecting common bits between the two genes. Now mutation. It chooses common bits so they can match up and then add it to the child. But now mutation is just randomly switching parts of the child's genes to prevent falling into local minima, which means that it's just trapped in a loop where it can't escape. And this is a little example. It's a little bit extreme, but it does work. So this 0 turned into a 1, and then this 1 turned into a 0, and this is a pretty extreme example, but there is one. This is another picture. How does it help? How does it help, and why is it useful? So selection helps by making sure that the best amount of time is achieved by not spending time on other less efficient paths, as to not waste resources either. Crossover creates the next generation and keeps them similar, so it doesn't become too random where it's like 1, 0, and then just everything flips. So it won't be like Google's random number generator. And mutation helps by not trapping it in a loop where it's the exact same, so the same genes gets repeated forever, and then it never arrives to its final best solution to this. And yeah, that was the explanation part. Let's go on to the coding part. Okay, that was good. Okay, so now let's get on to the coding part. So this will be a relatively short part. So what we're gonna do is we're gonna write. You also have to open command prompt, and you're gonna write pip install pygame. I mean, no, not pygame. You're gonna write pip install numpy, as we will be using this. We'll be using that to calculate everything. So after you do that, what you're gonna write is you're gonna write import numpy. I already have it installed, as you can tell. Now what we're gonna do is we're gonna go down to, we're gonna write equation inputs. There we go. Now what we're gonna write in here is we're gonna put bracket. We're gonna put a big bracket. We're gonna write 4. We're gonna write -2. Well, you can write whatever you want, but I will be writing these, so I'll write 3.5, and then I'll write 3. Nope, 5 I'll be writing. And then I'm going to be writing -11, and then 4.7. If you want to write exactly what I wrote, you can go ahead. You also do have to write it properly. Guess that's a slight oversight. There we go. So now what we're gonna do is basically what this is just the inputs. This is just the inputs. Let's just write inputs of equation. I would suggest you writing this too, so you can remember if you ever come back and open this and have no idea what it says. So this is the input of the equation. What we're gonna write is num weights, and we're gonna write equals len equation inputs. There we go. Now we're gonna go down again. We're gonna write number of weights to optimize. There we go. This is, I guess, basically what it is. Actually, we will be creating another file after this in the part 2. Now we're gonna write import. Whatever you're gonna call your file, write that. I'll be calling it GA. So now what I'm gonna be writing is gonna be writing sol per pop. And there we go. Now we're gonna write 8. We're gonna write NPR. There we go. Equals 4. There we go. Okay, those are just kind of variables just to keep everything in line. Yeah. So now what we're gonna write is we're gonna write pop size. So this is just defining the population size. Actually, let's real quick. Defining population size. There we go. That means the pop size will be, we're gonna put parentheses, and we're gonna write sol per pop, and a comma. Then we're gonna write num weight. There we go. So now we can go down. That was basically defining the population size. We're gonna create the first population that we've just defined there. So creating first population stated above. There we go. Okay. Now we're going to write new population. Population. I'm gonna put an enter. What we're gonna write is we're going to write a simple. Okay, first we have to make it random, I guess, because it will be in a certain range. Dot random. Maybe if we didn't put a space, that'd be nice. Dot random. Then we're gonna write dot uniform. And the lowest we're going to set, I'm going to set it to. You can call this whatever you want. I will choose -4.0. So nothing stops. And then we're just gonna do for the high 4.0 instead of -4. Okay, so now we're gonna put another comma. We're gonna go down. We're gonna write size equals pop size. Boom. Okay. So now we're just gonna write print new population. Simple as that. Right. Now we're gonna go down to. Okay, so we're gonna write best outputs. There we go. And we're just gonna leave an empty box. We're just gonna leave an empty array. Now, how many generations you want? Num gens. I'm going to write. Let's go with 1,000. Now what we're gonna write is we're gonna write for gens for generations in range. Actually, you might be better off writing gens. Now what we're gonna do is we're gonna write where's num? Oh wait, num gens. There we go. Okay, we're just gonna put a colon there. We're gonna write print generations or generation colon, and we're gonna put a comma. Then we're gonna write generation. Just gens. Actually, just to make sure that nothing breaks, we might write generate num generations. Okay, now we're gonna go down here. We're gonna write generation. There we go. Now what this is doing, might as well put another note here, is just measuring fitness. Basically saying optimized. There we go. Now what we're gonna go down, we're gonna write fitness ga.cal pop fitness. We're going to write equation inputs, comma, new population. There we go. And then we're just gonna write print fitness. And then we're just gonna write, no. Now here we're gonna write print fitness. There we go. Now we're gonna go down again. We're gonna go down to, we're going to write best output dot append. Actually, we do need to go up one, so there's that. And write numpy dot max and we're gonna put that. Now what we're gonna write in here is numpy dot sum. I'm going to put another parentheses. You're gonna write W population. W population. Now what we're gonna write is okay, so you do need to add a S there, because up here, also we have to make sure that we spell this correctly. Population. Now we're going to do times equation inputs. There we go. And we're going to do comma, and we're just going to write axes equals 1. Now we can leave that. I'm going to write print best result equals, like, colon. Then we're going to write comma numpy dot max dot max yeah, we're basically just writing the same thing that we wrote right here. So we could just copy that and then paste that right there. Okay. So now what we're gonna do is we're just going to go down. We're going to write, we're just gonna write P, just to keep it simple. We're going to write GA. This doesn't exist, but you will have to get it later. Well, I mean, we'll type it in later in the next episode of this. Right, new population. Now what we're gonna do is we're gonna do a comma. Right, fitness. There we go. Now we're gonna put another comma. Right, num. I'm just yeah, just write M. I'm pretty sure that would work. And then what we're gonna do is we're going to write print parents. No, I know, just P. There we go. Okay. Right. Offspring Crossover equals GA dot crossover. I'm gonna write P. And that's it. Wait, no, actually what you do is you go here, you put a comma. What you're gonna write is you're going to write offspring size. There we go. Yeah, see, like that. You're gonna put that, and we're gonna write pop size 0. There we go. Minus parents dot shape. Wait, let me try P. Yeah, it's P dot shape. Okay. So what we're gonna do is we are going to write. We're gonna put another 0, and then we're gonna put a comma. We're gonna write num weights, and we can go down. Actually, we might need one of those because we actually don't have that. Okay, so anyways, what we're doing is we're going to write print offspring crossover. Oh. Okay, so now what we're gonna do is we are going to write. Gonna go down to. Also, this is actually we have to add another. Here we'll just write generates next gen using crossover. Okay, so what we're gonna write now, we're going to go down one, we're going to put another one of those, we're gonna write mutations, there we go. Okay, so now what we're gonna write here, we're gonna write offspring mutations, or mutation. We're gonna write ga.mutation, write offspring crossover. We're gonna put comma, we're gonna write num mutations, and we're gonna write equals 2. And write print offspring mutation. There we go. Creating new pop based on parent and offspring. There we go. Now what we're gonna write is new population. We're gonna put big bracket. We're gonna write 0 colon parents. Oh my god, it always has to be p dot shape. And then put 0 in there. Now what we're gonna do is we're gonna put a comma after that. We're gonna write like that, so it looks like one of these faces. But you know, I'm gonna write equals p. New population. We're gonna write parent p dot shape. I'm gonna put 0. And we're gonna do one of those smiley faces again. And then we're gonna write offspring mutation. There. Okay, so now what we're gonna do, we're gonna write best match IDX. And then, actually we do have to go down a few just for it to look cleaner. We're going to write here, getting best solution. There we go. Now what we're gonna do is we're gonna put a space and then like that. Let's write numpy dot where. And we're gonna write, put a colon, we're gonna write fitness is equal to numpy dot max. And I'm gonna put another one, we're gonna write fitness inside it. Okay, now we're gonna write, when you go down 1 or 2, your choice, print best solution. I'm gonna write new population and put big bracket. We're gonna write best match IDX. There we go. Okay. So now what we can do is go one or two down. Actually, we do need matplotlib. So go into command prompt, write pip install matplotlib. I'm gonna put it on screen. Yeah. I'm gonna write import matplotlib.pyplot. There we go. We're gonna write matplotlib dot pyplot dot pyplot dot plot. I'm gonna write best outputs. What I'm going to do is I'm going to copy this, because we're going to type it a few times. So we're going to do that, and then we're going to write .x label. I'm going to put iteration. There we go. Do it again. Now we're going to write .y label, and then we're going to write fitness. And we're going to paste that in again. We're going to write pyplotlib.show. And, well guys, that was the end of the video. I hope you enjoyed. If you did, make sure you like and subscribe. It really helps me out a lot. And you can always unsubscribe later. But we're done. I'll see you in the next video, hopefully. Bye.
Second part.
We'll be continuing on with ga.py, or that one import that we made at the start of the code, at the start of the video. So now let's get started. So we're going to write import numpy, just like we installed last time. We're going to use it again. We're going to write def cal pop fitness. There we go. Now what we're going to write is equation inputs. Okay? And then we're just going to write pop. There we go. We're going to put a colon there. This is calculating fitness values. No. Calc fitness values of each solution. I would suggest you write these down too, so you have what it's writing. Okay, so now we're going to continue. We're going to write fitness equals numpy dot sum. I'm going to write pop times equation inputs, comma, axes will equal to 1. There we go. Now we're going to go down one. We are going to write return fitness. There we go. Okay, so now we're going to make another one, so we can leave that function. We can write def select pool. Now what we're going to write in here is we're going to write pop fitness and num parents. There we go. Okay, so now we're gonna put a colon. We're going to write parents equals numpy.empty. There we go. I'm gonna put two of those. I'm gonna write num parents and pop dot shape. Now, there we go, we can just do that. Okay. So, yeah, we can just, actually we do have to move this all the way back here. Just like that. Okay, so now what we're going to do is we're going to write for parent num in range we're going to write num parents. There we go. Gonna go down one. I'm gonna write max fitness idx equals numpy dot where. I'm gonna put one of those. We're gonna write fitness is equal to numpy okay, what we're gonna write here is we're gonna write numpy dot where. Wait. Yeah. And then we're gonna write fitness is equal to numpy dot max. Now what we're going to write is we are going to write, well, we're going to go down, we're going to write max fitness idx will be equal to max fitness idx, and we're going to put that, then another one. Okay. I'm going to write parents I'm going to put that. We're going to write parents num. We're going to just put a colon. There we go. Okay, now we can go down. You can write fitness. You can put a box there. We're going to write max fitness idx equals negative. There we go. Now we're just going to write return parents. There we go. Now we can write def crossover. We're going to write parent offspring size. There we go. I'm going to put colon there. We're going to write offspring is equal to numpy dot empty. I'm going to write offspring size. There we go. You can go down. You can write cross over point is equal to numpy dot uint 8. I'm gonna put parentheses. I'm gonna write offspring size. We're gonna put in here 1, and then we're gonna put a slash, and then we're gonna put another one. We're gonna write 2 inside it. There we go. Okay, now we're gonna go down and write for k in range. I'm gonna write offspring size 0. There we go. Now we can go down 1. We're going to write parent 1 idx will equal to k, this symbol, parents dot shape. I'm gonna put 0 there. Now what we're gonna do is we're just gonna copy this. Just gonna do that, but we're just gonna change this to 2. And we're just gonna do k. We're gonna put parentheses there, and we're gonna write. Okay, and we're just gonna write plus 1. And there we go. That's that part. I'm gonna write offspring Now what we're gonna write, offspring, we're gonna put that, we're gonna write K, then we're gonna put a comma, we're gonna put 0 equals, 0 comma, crossover point, there we go. Now we can go down one, no we can't, we have to put a space. We're going to write parent, I'm gonna put parent1 idx, then we're gonna write 0 crossover point. Okay. And we're basically just gonna copy the same thing. Nope. Just gonna Control C that, and then we're gonna Control C V that. Gonna go all the way down here. Fix that little bug that we added there. Now we're gonna change this to, instead of parent1, we're just gonna change this to parent2. And also we do have to remove the 0 right here. Crossover point like that. Now, what we're gonna do is going to delete this, but we will have to put it at the end. There we go. Okay. So now what we're gonna write is we're gonna go down, we're gonna write return offspring. Now this is where we'll do the mutation. This is basically just taking the genes of the first parent and then the second parent. Combining. This doesn't really have an explanation, it's just some extra values. Now what we're gonna go down to, we're gonna write def mutation. I'm gonna write offspring. I'm gonna write cross over. There we go. I'm gonna write num mutations. There we go. We're gonna put equals 1. Okay, we're gonna put a colon there so we can go down 1. Okay, so now what we're gonna do is we are going to write mutations counter. Then we're going to write equals numpy dot uint8. And then what we're gonna write in here is we're gonna write offspring crossover dot shape. And we're gonna write 0 in here. There we go. Now we're just going to go here. We're gonna divide it by mutations. There we go. Okay. Now we can leave this. What we're going to write now is for idx in range offspring crossover dot shape 0. There we go. Gene idx equals mutations counter -1. There we go. Now we're going to go down. We're going to write for mutations num in range num mutations. There we go. What we're going to write is random value equals numpy dot random dot uniform. I'm going to write -1.0 1. Actually, just 1.0. Then we're going to write 1. That's it. Okay. Now what we're going to write, we're going to write offspring crossover. I'm going to write idx gene idx equals offspring crossover idx and then just gene idx. There we go. Plus random dot value. Now what we're gonna do now is we're going to write gene idx equals gene idx again plus mutations counter plus mutations counter. There you go. Now we can just go down to, we can leave the for loop so it stay in the function. Now we're gonna write return offspring crossover. Now let's see if it works, and yeah. And I'm about to run it. Let's see what happens. And what do you look at that, guys? It worked. Let's let it run. Yeah, and it just found the best solution. And now, also it does launch this, which I completely forgot about. Shows you a little graph of everything, very convenient. Yeah, everything, all of this is in the description. All of the code is all in the description. If you want, you can go and check it out in the description. Go, use that. Yeah, guys, that was the video. I'll see you guys later, and goodbye.